Okay, so let's begin. This is an extra lecture. I would like to go through this integration killer basic questions. Where for the viewers online, I'll put the link below for you to access them. Alright, you may try the questions on your own first. They are all looks very similar, but with a very slight distortion here and there. I personally will do this type of questions whenever before I go to exam hall. Alright, and I suggest you keep this paper with you because you're going to use them over and over again. Last year when I write this one, I wrote this exact question came out in exams. So I wasn't sure whether my student actually studied them. Okay, so let's begin. As you can see, there are many types of fraction over here. Until question 9, all of them are fractions. Okay, so number 1. If x plus 1 over x dx, how I see this question is that I can split it up. Okay, so I can get myself x over x plus 1 over x dx. X over x easily become 1, and 1 over x remain as 1 over x. Integrating them, integrate 1, x, integrate 1 over x, on x. Of course, don't forget your plus c. This one is still easy. I can see that I can split it up. Alright, so let's continue. The next one will be x over x plus 1 dx. The common mistakes I got from students, either they want to split the same thing, so they get themselves into x over x plus x over 1, but this idea does not work. I can give you a small example. If I write down 2 over 4 plus 6, I cannot split 2 over 4 plus 2 over 6. The idea does not work. So this is a common mistake. Another common mistake I got from students is that they see that, oh, I bring this x outside, 1 over x plus 1, then this one got ln x plus 1 times x. This is another common mistake. The thing is, you cannot take x outside because x is a variable. You can only take constant outside. Only constant. So this is a totally wrong method. People at the back, can you hear my voice? Okay, sorry if I'm a bit soft here. So the correct way of doing this question is by realizing that they have the same power. This one to the power 1, this one to the power 1. So they have the same power. It's either you can use long divisions, you can get the answers. You can also use substitution for you to get the answers, but substitution is a bit long. The best way to proceed is by realizing I want to get things the same between the top and bottom, between numerator and denominator. What's the difference between top and bottom? This one has plus 1, this one does not have plus 1. So I put plus 1 and I minus 1 back. Because plus 1 minus 1 is equals to 0, so basically I'm adding 0. And when I add 0, it means nothing. So I can split it up, x plus 1 over x plus 1 minus 1 over x plus 1 dx. So x plus 1 over x plus 1, you can cancel it out, I get 1. This is of course a faster method compared to the long division. Now only integrate it up, integrate 1, I got x, integrate 1 over x plus 1, it's a ln x plus 1 plus c. Let's say you have done this and then one day you become very good in it, then you may skip the process to here straight away. One day you have become good. Alright, can I continue? Yes. Next question. Okay, let's say you're given this. whenever I see a fraction question, fraction for integration, the first thing came to my mind is what happens if I differentiate this? Will I get the same as top? Integrate it, if I differentiate, I get myself 2x, here is x, the difference is I just need 2. Normally I'll do this way, 2 over 2, where 2 goes inside, so I get myself 2x, 1 over 2, 1 plus x squared. So now if I differentiate the denominator, I get 2x, that's what we wanted. So I'll get myself straight away ln 1 plus x squared. Yeah, if you differentiate, you get the top, means you got the ln plus c, and of course this 1 over 2. Okay. If one day you become good in this, this is how I'll do the questions. One day you become proficient, I will personally just differentiate top. I got myself. I might write this one down to x just to be confirmed. I realize I don't have to, so I just do this and do this, and straight away I give the answers. One day when you become very good. Okay. Can I continue? Okay, the next one is question number 4. The one with the square root. But for these particular questions, I can see that there's no x at top. Okay, only x at bottom. You can see here no x. Or numerator, you can call it that way. So I can bring this equation up. Bring up. So I get myself 1 plus x. Square root is to the what power? 1 over 2. So if I bring it up, it becomes negative 1 over 2. Okay, remember whenever fractions you bring it up, you got negative. Some people forgot about it. So now you just integrate as usual. So you plus 1. One over 2, and then divide by 1 over 2 plus c. Of course, you cannot leave your answers in this way. You need to solve this 1 over 2. You cannot have fractions below. So you got yourself 2, 1 plus x, 1 over 2 plus c. This is okay. Of course, some of you might want this answer instead. Both of them are acceptable in exams. Are you okay? Can I continue? Are you okay? Yeah? Okay. Next one's number 5. Alright, the difference between this and the previous one is that there is x at top. The last question, there is no x at top. There are multiple ways of solving this. I think substitution can give you the answers, albeit a bit annoying if I'm not mistaken. But another formal way is, of course, partial fractions. Let's do the sub first. If you do the substitution, you take this, the bottom. Let u equals to 1 minus x. So du dx, you got minus 1. So du dx, there's no negative over here, so I put negative to the left side. And if you try to substitute, u equals to 1 minus x. So down here, dx here, with dx here, but we still have the extra x. So what should we do with it? We need to manipulate, substitution manipulation. So you got yourself x equals to 1 minus u. So all the substitution will give you 1 minus u over u squared negative du. Negative du you can put outside. But for this particular question, say this negative can sort of simplify these things. You got yourself u minus 1. And that's more comfortable in my opinion. And how do we proceed from here? Now from here, then we use our original technique just now. We split it up, you can see. The split is easier if you got it's only one letter down there, but sometimes you can split even two. But that's rare. See? And you can see here easily 1 over u minus. Is it the same thing? Oh yeah, u squared. I miss it. Thank you. This one here is integrating ln u. What about this one? You bring it up. I mean, let's do it separately a bit. You're integrating 1 over u squared u negative 2. So u negative 1 over negative 1, and that is negative here, so they can cancel up. Plus c and of course you can rewrite the whole thing. One moment. Ln u minus 1 over u plus c. Should you leave your answer in this form? Completely no. You should substitute back with what you started, 1 minus x ln 1 minus x minus 1 over 1 minus x. Yes, a bit of clarification. In some syllabus they do in modulus method, but in examinations, well, both of you get the same marks anyway. Can I move on? Okay, I'll show you another method, which is the partial fraction method. So I can see that this is a repeated case. And remember, some people, even my top students, sometimes make these mistakes. How do you make this one disappear? We cross multiply them. One minus x squared. So you got 1. Yeah. And this one here, squared, so it disappears. So just b. So now how you solve them? Well, let's try to make this one disappear first. Let x, normally I use blue. Let x equals to 1. So 1 equals to 0 plus b. So we know b is 1. And how you find b? How you find a? Now just substitute any numbers. I like to substitute that. Small numbers will be let x equals to 0. So 0 equals to a 1 plus b. But b we just discovered just now. B is 1. So a is negative 1. Once you got this far, you substitute back. Substitute back into here, which give you negative 1 over 1 minus x plus b is 1 over 1 minus x squared. Class, are you okay? Now we got ourselves into fractions again. This one differentiate, you get yourself -1, voila, -1. So it's pretty much easy from here. Ln 1 minus x. This one here, there's no x at top. So how should I solve? I bring it up because there's no x at top. Let's do it by the side. Integrate this one. 1 minus x over power of -1, -1, and differentiate inside, also -1. And of course, as your final answers, you can rewrite the whole thing as, it's a bit paper left, ln 1 minus x minus minus plus 1 over 1 minus x. And yes, please don't forget your plus c, which I kind of forgot just now, but I recovered at the end. Okay, if I'm not mistaken, the answer is slightly different. Is it the same? The main difference is because it's minus, this is plus, is because of this plus c. Let me check with my notes. Oh my, did I make mistakes over here? Oh, sorry. This one is already plus. Okay. Minus minus plus. I did not change it here. I forgot. Okay, a little bit of disclaimer. This the notes. This one is wrong. This is plus. For the partial fraction. The partial fraction, this is plus. Okay. Okay, let's continue. Just now is number 5. So now is number 6. What about this one? Since there's no x at top, so we got ourselves bring it up, 1 minus x minus 1. This one is the same as just now. Differentiate inside, -1 plus c 1 minus x. Yep, completely correct. Can I continue? So next one, number 7. All right. This time with the square root fraction, at the same time there's x at top. What's the best way to proceed? Substitution is the best. When you see a square root, most of the time is substitution. With the power or without the power? With the square root or without the square root? With the square root. I highly recommend you take with the square root as well. Because then you can do this process, u squared 1 minus x squared, the square root will disappear. And once the square root disappears, then only you differentiate them, 2u du dx. Okay, for this method you need to memorize, at least understand this one. Differentiate u squared, 2 go in front u, but since we differentiate to the respect of x, so it becomes du dx. Differentiate this, negative 2x. And as you can see here, this 2 and 2, we can simplify it. So now u du equals to x dx. But I cannot see negative over here, so it's best for me to bring this negative to the left side. Now we substitute them. This thing, the whole thing. And this thing here, x dx. Can I find x dx? Yes, I can. But there is a question, sir, do you do the same thing, circle things in exam, sir? Yes, I will, because it can help me avoiding careless mistakes. Well, I use this only one color. And I've seen a lot of students who don't do it, make mistakes. So x dx I replace with negative u du. Negative u du. Negative is a constant, just pull it out. U over u. So I get myself 1 du negative. Integrate 1. Integrate 1, what do you get? U or x? U. Why u? Why not x? Because it's du over here. Okay, make sure you write things correctly. Same way, if you want to say to your girlfriend, make sure you use the correct name. If you're a player, be extra careful. I got a friend who have 2 girlfriends at the same time, and one day he wrongly texts the name to different girls. Okay. Is that the same as the answer? Yep. In fact, I got a professor who forgot his own wife names. He called his second wife with the first wife name. He told it in my class. Let's not talk too much about him. Okay, continue. How should we continue? The best way is to expand, I thought. If you can expand, you expand first. That's the rules number 1. X squared plus 2x plus 1 over x. And then you split it up. Which give you only that one we can solve. I mean, that one completely disappear. This one becomes x minus 1. Oh, no. Let's remain it as this. So now what do we get? Integrate x. X squared over 2. Integrate 2. Integrate this one. Ln x. I got a lot of students who... Let me finish my talk. My students is being kiasu with me. Okay, I'll be honest, I forgot this now. I got a lot of students who do this thing this way instead. They bring it up, and then suddenly they realize, hey, x0, 1. Obviously, this is the wrong answer. Okay, remember if 1 over x, differentiate, you got top. Differentiate x, you got 1, so ln x. Yeah, I put, it's up to you, want to put modulus or want to put bracket. Can I continue? So yeah, expand if possible. Okay, number 9. Over here, the questions I did not. I don't want to do all of it. Okay, I just want to know the formula. What's the best way to proceed? The first one is partial. Why partial? Because you can see I have 2 factors, okay? What about the right side? How do you solve it? This one here, you can factorize, so what will you get? X plus 1. So basically, the same thing. So yeah, if you see the denominator, check whether you can factorize the deno. Okay? You factorize the deno, and then you see yourself got 2 factors. So it ultimately means it's a partial fraction. Do you want to try this question? Shall we try? So we got ourselves the same technique just now. We multiply this to issue one of them. How do we proceed? Well, the easiest way, let's make this one 0 first. So A is 1. And the other one will be -1. 1 equals to 0 plus negative B. So B is -1. I believe this one, the answer is not included. Let me think. So 1 over x minus the substitute inside here. Now integrate that. What will you get? The left side is ln x. The right side is ln x plus 1 plus c. I would like to go one step further, because this thing I can combine. Ln x over x plus 1. Should you do these steps? Mostly the answer is yes. It depends on the questions. But I'll say mostly yes, because you're going to substitute things, then things becomes a lot simpler most of the times. It depends on the questions. Okay, number 10, sort of my favorite. Not my favorite. Okay, it's a student favorite, careless mistakes. That's a bit cruel, sir. You did it yesterday. Okay, now how do we integrate this one first? IBP, integration by parts. Why? Two different types. This is algebraic. This one is a trigo. So it's an IBP. IBP, you want to differentiate one thing and you want to integrate another thing. Which one you want to differentiate? Yx. If you differentiate x, you simply got 1. Make it simpler. So when we want to integrate cos x, sin x. So now My method is I like to use pattern method. So one less thing to memorize. Minus integrate of sin x here. Integrating sin x, negative cos x. Yeah, this is the only one. Oopsie, wrong symbols. Sin x, okay. Negative, positive, negative, negative. Positive cos x. Are you okay? Are you okay, class? Huh? Why no plus C? Because we got integral, okay? The moment if I ask you twice, it means something. Okay, now you need to substitute those two values. Pi over 2 and 0. Here comes the careless mistakes. Okay, pi over 2, let's substitute them first. I'm a big fan of once we finish things, I substitute all of them at the same time. So the left side is when you sub pi over 2. The right side is when you sub 0. Let's do the right side first, it's easier. Right side, you get yourself 0 sin 0, 0 cos 0, simply 1. So negative 1. Okay, now the complicated part. Cos pi over 2 will give you what? Cos pi over 2. Someone got no 0? Cos pi over 2, what do you get? May I know the one that didn't get 0? Please raise your hand. I just want to show this careless mistake. Did someone get not pi over 2? Cos pi over 2, what do you get? Siapa tak dapat 0? Raise your hand. It doesn't want to mengaku here. Okay, but some of them, yes, they got the same. They got different. What happened is this. Can I borrow your calculator? Yes. For a while. Because I got the hunch you didn't get it. Oh, okay. He's blaming someone else now. Well, this is the common mistakes in exams. You press this cos pi over 2 and you got the different answers and you're wondering, why the other people got 0? I didn't. I got 0.9, right? No, 0. It's because pi is in radian and your calculator is in degree. That's the problem. So yes, you need to change this to radian. Okay. Or my favorite will be, I will personally change it like this. I will just, pi over 2 is 180, 180 over 2 will be 90, 90. I will change it here. Okay, so then I'll just press my calculator, cos 90, 0. So it solved the problem. Sin 0, sin 90, 1, yeah. And then the careless mistake does not stop there. They continue with pi over 2. This is 90, 90, 90. So this is also they put 90. It happens. And I said, no. You remain it as pi over 2. And I said, but just now we do pi over 2. We don't get the answers. They start to cry. And I said, no, that's trigo. And then they start to argue with me, sir, why maths is so difficult, sir? What's the usage of maths in our lives, sir? And so on. It happens like that. It happens. I've seen that multiple times. So yes, the answer in the end is pi over 2 minus 1. Yeah, if the question asks you, give your answer in exact form, which is the one in pi. What happened if, sir, can I just simply press my calculator magically and get myself into decimals, and isn't that fine, sir? Well, I have to agree with you, it's okay. Let's say they got this, everything in decimals. Isn't it okay, sir? Well, the exam question nowadays, they want your answers to be in exact form. They want to make sure you can't use your calculator. Okay? So, I'll say practice for you to get here. Thank you. Sorry about the sad face. Continue. Life is cruel. Exam's going to be give you the curveball. All right, let's continue. My pen's running out of ink. Okay, this is Monami. Oh, popular. To the any stationery, I mean, company, you may, what you call that, advertise, sponsor me the pen so I can, you know, buy this pen, it's useful for your life, and you got you got straight A's in exam, 4 flat. Man, I wish I can be rich. Continue. Okay, how do we proceed? This one is E negative X, right? So what should we do? Yes, my brain works the same way. I know this is 1 over, so I put another 1 over here. Technically, that's how even I myself think about it. And then you realize, oh, this is multiplying up there. Of course, I got students, or even sometimes me. Sometimes I might do this straight away. You may skip the steps if you can see it. If you can't, do them step by steps. If you can't even more, then add another step of this. This is another extra steps, if you could not really see it. Okay, so from here, how do we proceed? Expand, yes. Good eyes. So we got ourselves dx plus e to x. Now, how do you proceed? Integrate straight away, integrate ex. Yes, integrate e to x. E to x over 2 plus c. Okay? You guys okay? We're almost done. Let's say now you integrate ln x ex, where I write here the tips. Integrating ln x dx is equals to x ln x minus x plus c. There are some people who agree that we can do this straight away without using the IVP. Some people disagree. But never mind, let's argue about this one. How do we integrate this part? Break them. This one, it follows from ln AB, which is ln A plus ln B. So yes, we break them apart. Sorry, or we split them apart. Okay, how do we integrate ln ex? Let's do this one. This is a power, right? What can I do with the power? You bring it in front, x. Ln e equals to what? Ln e equals to 1. So simply ln x plus x. Well, I give you the tips over here just now. And over here, integrate x plus x squared over 2 plus c. I guess I show a bit how we got this one. Just a little bit of show. A quick one, integrate ln x. You differentiate ln x, get yourself 1 over x. Yeah. We integrate 1 x. So from here is just IBP. I'm going to be a bit quick here. X ln x minus, combining this, I can simplify here, 1 dx. This x plus c, x ln x. You get used to it one day. We can do it quickly. And the final questions here written. Cot over x is 1 over tan, you can say that, and then cos to x over sin to x. If you are good, you may skip the process, but the number of students doing this is getting more and more nowadays, which is worrying. This is bloody. There's only 2x, they need to have split over there. And what's the best way to continue from here? What's the best way to continue? When it comes to trigo, everyone is waiting quiet. Let you which one? You can do let you equals to sine 2x. So du dx cos 2x. You okay? You differentiate this one as well, 2 cos 2x dx. But there's no 2 over here, so the 2 I bring it over this side. And now you substitute them. Cos 2x dx this one here, 1 over u. This one, the cos 2x dx. I got myself 1 over 2 du. Integrating 1 over u, ln u. Are we okay as this as our final answers? Why not? You need to sub back. You need to sub back your u, so you got yourself ln sin 2x plus c. Okay? You got the answer, but that is not the best way. There is another better way than this. If I were to do this question, this is how I do. I see this, I straight away go here, and then I realize myself, hey, differentiate sin 2x give me what? If I differentiate this, I got myself 2 cos 2x. Cos 2x there, so it's good already. I can go to ln straight away. But I don't have these 2, so what should I do? I add 2 here, I add 1 over 2 outside. So straight away, yeah, I just rewrite things back a bit. So straight away give me 1 over 2 ln sine 2x plus c. So obviously this is superior. Maybe a little bit of bonus questions. A bonus question will be something like this. A simple one, because I've seen a lot of people make these mistakes. What's the best way to proceed? I won't say IBP is wrong, but I'll say before you do IBP, there's a shortcut. This is a power, right? I can bring it in front, but I can bring it out straight away. Yeah, that's a super shortcut. So x ln x dx. Now you may use the IBP that you like so much. Okay, if you do IBP, which one you differentiate, which one you integrate? You differentiate ln x, you integrate x. Remember, you can never integrate ln x, so that's why you differentiate it. And this one here, I'm combining these two. Does our co-op sell this marker pen? So this one here we got ourselves squared over 4. Oh, see. It's a calculator, not a phone. Don't worry. Are you okay with it? Okay, one last bonus. Yeah, the thing is, I see it. I began to see it, and I was like, the heck. Okay, last one. This is last. Ln Ex minus ln x. Ln Ex, x bring in front, x ln E 1. And IBP, I hear that, I heard that. You're gonna IBP how? We differentiate this, we integrate this. We speed it up even more. This one becomes x squared over 2. This one becomes, yeah, if you tie it like me, x ln x minus x plus c. See, that's why I say we can, because you got used to it in the end. Of course, it's negative. Okay, I think that's all for today. It's time for Jumaat prayer over here in Malaysia. Alright, thank you for coming. That's all. Leave the comment below, and I'll put the updated questions online soon with the link below. Okay, thank you. Bye.